Now let us start students semiconductor devices. Before this, we'll discuss what we did in 11th standard. 11th standard, there are two types of semiconductor, P-type semiconductor and N-type of semiconductor. With this P-type and N-type semiconductor, we can make PN junction diode. So PN junction diode consists of P-type semiconductor and N-type of semiconductor. This is junction of PN junction diode. In P-type semiconductor, majority charge carrier as a positive, that means holes, and N-type semiconductor, majority charge carrier as a electrons. At the junction, if you see carefully, the few positive charge ions cross the junction and reached in an N-type of semiconductor, and few electron crosses the junction and reached in a P-type semiconductor. So because of this charge carrier positive and negative, there's a region is formed. That region we called as a depletion layer, and this positive and negative charge built up a potential. That potential we called as a barrier potential. Approximately it is order of 0.7 volt. This is symbolical representation of PN junction diode. This anode is positive, this cathode is negative. We can see a diode you can connect in forward bias and reverse bias. In forward bias diode, the P-type of semiconductor is connected to positive battery and N-type of semiconductor is connected to negative of battery. If you do this way, if you see carefully, this is a positive, this also positive. So between this positive of battery and this positive charge carrier, there is a repulsion takes place. As a result of this holes, that is positive charge carrier, crosses the junction and flow in this direction. Where this negative electron and negative battery, again there is a repulsion takes place and this electron gets repelled this side. That's means hole crosses the junction and electron also crosses the junction. This depletion layer decreases in forward bias. That means resistance decreases in forward bias. So electron flow in this direction. So flow of electron this way, right? This is a flow of electron, but we are taking conventional current, that is opposite to flow of current. That means conventional current in this direction. That means diode conducts only in forward bias. Okay, I repeat, forward bias means positive battery is connected to P-type of semiconductor and negative battery is connected to N-type of semiconductor. And in forward bias, diode conducts. In reverse bias means P-type of semiconductor is connected to negative battery and N-type of semiconductor is connected to positive battery. Now this is negative and this charge carrier, that is holes, as a positive. So between positive and negative there is a attraction. So holes gets attracted to this side and electron and this positive, again there is an attraction, so electron get attracted on this side. So there is the depletion layer increases in this case. That means resistance increases. So there is a no flow of current in reverse bias. But students, keep in mind, because of this depletion layer, that is barrier potential which is set up here, because of this positive and this negative, a small amount of current flows in reverse bias. That current is very small because of this minority carriers and is order of normally microampere. Yes students, next part now. Block diagram of DC power supply with waveform at its stage. Also we can say block diagram simple rectifier circuit with respective output waveforms. Now first of all, the transmission of AC power, this AC power is effective and economic than transmitting a DC power. Means whatever power is generated at power station, that is AC power. Now from main station, this AC power is transmitted from one place to another place. And in some cases, we have to convert this high voltage to low voltage or low voltage to high voltage. This job is done by what we called as a transformer. So main purpose of transformer is device used for changing the voltage of AC from high to low or vice versa. So when it's converting from high to low, we called as a step down transformer, and when it is converting AC low to high, we called as a step up transformer. But in AC source which we are there at home, there are many gadgets, that is TV, mobile chargers, they are working on a DC supply. That means we have to convert AC to DC, and this part what we have to see with the help of this part. This is basically what we are inside the DC power supply. So our AC main source, which has a 230 volt and 50 hertz, this AC we indicating with this way, right? This transformer, here we are taking a step down transformer. This AC signal, it gets through the transformer, it convert to high voltage to low voltage. If it is step up transformer, then it will convert AC low voltage to high voltage. Here if I take step down transformer, then it converting the AC high voltage to AC low voltage. Fine. Then we are using a rectifier, diode rectifier. There are two types of rectifier. We have half wave rectifier and full wave rectifier. This diode rectifier converts, if you see, the diode rectifier AC voltage to DC voltage, that is pulsating. So function of diode rectifier to convert AC voltage to DC voltage, that is pulsating DC voltage. Then we have filter. What is the function of filter? Filter remove AC component from the rectified voltage. It means after a diode, function of diode is to convert AC voltage to DC voltage, that is pulsating DC voltage. This DC voltage consists of some AC component also. पूरा DC voltage रहता, प्योर DC voltage यहाँ पे रहता नहीं है, इसके अंदर थोड़े से क्या होते हैं, AC component भी होते हैं. So filter to remove the AC component from the rectified voltage. तो ये जो voltage आएगा इसमें से AC component को निकालने का काम कौन करेगा? Filter. So we say filter used to remove the AC component from the rectified voltage. So once the AC component is removed, we will get waveform something like this. Then the function of voltage regulator. This voltage regulator provides the required DC voltage. In simple language, we can say, students, at power station we are generating AC. That AC we have to convert in low voltage. We require a transformer. Then diode rectifier. This diode rectifier convert AC signal to DC pulsating. Then this DC has some component of AC that is removed with the help of filter circuit. And after passing through the voltage regulator, we are getting a required DC voltage. Now rectifier. First we have half wave rectifier. Now half wave rectifier, in transformer towards the primary we are connecting a AC voltage, and secondary of transformer we are connecting a series, a diode. It consists of single diode and load resistance RL. Now this is what we can say, the AC signal in waveform, that is graphically we have shown here the input voltage. This we called as a positive cycle, this we called as a negative cycle. This is next positive cycle, this is next negative cycle. So when a first positive cycle, that is positive half cycle, this we can say positive half cycle. During positive half cycle, this A is positive with respect to B. So positive cycle, if A is positive with respect to B, that means this positive is connected to this positive. That means this diode is in a forward bias, and we know diode conducts only in forward bias. So during positive half cycle, as A is positive with respect to B, diode D is in forward bias. As a result of this, diode conducts and current flow through the load resistance IL in this direction. Now during negative cycle, A is negative with respect to B. अभी अगर A negative हो गया, so this is negative, this is positive, this is negative, this negative is connected to positive. That means diode now is in a reverse bias. If diode is in reverse bias, diode does not conduct. As diode does not conduct in reverse bias, current through the load resistance will not flow. मतलब reverse bias में current flow होने वाला नहीं है. Again next positive half cycle, again A is positive with respect to B. As A is positive, diode is now in a forward bias. As diode is in forward bias, diode again conducts and current flows through the load resistor IL in this direction. Next negative cycle, again this is negative with respect to B. So this is negative, so diode is in reverse bias, diode फिर conduct नहीं करेगा, current flow होने वाला नहीं है. That means I can say the diode conducts only in a positive cycle, so output you will get only in a positive cycles. This is input, positive, negative, positive cycle, negative cycle, positive cycle, negative cycle, but diode conducts only positive cycle. So this is input. Output you will get only in a positive cycle. Negative half cycle में output मिलने वाला नहीं. Again positive half cycle will get the output. So we are getting output only in a positive half cycle, and that is unidirectional because current flows in same direction through the load resistance. So if you see here in shortcut, positive half cycle A is positive with respect to B, diode forward bias and it conducts. Negative half cycle A is negative with respect to B, diode D in reverse bias does not conduct, and current flows through the load resistance in the same direction for alternating positive half cycle. Okay students. Next part students, full wave rectifier. It consists of two diodes D1 and D2. The primary of transformer is connected to again AC source. Secondary we are connecting diode D1 and D2. There is a central tap C, that is ground, and we are taking output from here and negative of diode through the load resistance. So we are taking output across the load resistance. This is input voltage, that is positive half cycle, negative half cycle, next positive half cycle, next negative half cycle. Now during positive half cycle, A is positive and B is negative with respect to central key, that is at ground. So we can say positive half cycle, A is positive, B is negative. A is positive, B is negative with respect to central tap C, that is at ground. As A is positive, so positive is connected to positive of diode D1. So D1 is in a forward bias, and B is negative, so negative is connected to positive of diode D2. So D2 is in reverse bias. So in simple language we can say during positive half cycle, D1 is in forward bias and D2 is in reverse bias, and because of this only diode D1 conducts and current flow through the load resistance. The path followed by current we can say A, P, Q, R and C. Path followed is A, P, Q, R and C. So we can say here during positive half cycle, A is positive, B is negative with respect to central tap, that is ground. D1 is in forward bias, D2 reverse bias, does not conduct, D1 conduct. Current IL flows path A, P, Q, R and C. In negative half cycle, A is negative and B is positive with respect to central tap C. As A is negative and diode D1 this is positive, so diode D1 is now in a reverse bias. As B is positive and this is also positive of diode D2, so D2 is now in a forward bias. Means in negative half cycle, diode D1 is in reverse bias and diode D2 is in forward bias. मतलब अभी कौन सा diode conduct करेगा? Diode D2. So diode D2 conducts and current passes through the load resistance RL. Now path flow current is B, P, Q, R and C. That means in positive half cycle also current through this path, and negative half cycle also current pass through the QR. That means current is unidirectional. So if you see here it is negative half cycle, A is negative, B is positive with respect to central ground. So D1 is in reverse bias, D2 is in forward bias which conduct, and path followed we can say same B, P, Q, R and C. So if I see here, in this case positive half cycle we will get the output because of diode D1. In negative half cycle again we will get the output because of diode D2. D2 is on in negative half cycle. In next positive half cycle again we will get output because of diode D1. And negative half cycle you will get again output because of diode D2. So whether it is positive half cycle or negative half cycle, out of this two diode, one diode will conduct and you will get the output voltage. Because of this we called as a full wave rectifier. Next part, a ripple factor. The output of rectifier consists of a small fraction of AC component. along with DC called a ripple. As we discussed, we are getting the DC voltage, but पूरा DC voltage नहीं रहता है. रेक्टिफायर से जो फुल वे हाफ वे रेक्टिफायर से हमें जो आउटपुट मिल रहा था पूरा DC वोल्टेज नहीं रहता है. उसके अंदर थोड़े से AC कंपोनेंट रहते हैं. सो देयर आर AC कंपोनेंट अलॉन्ग विद द DC कॉल्ड एज रिपल. सो दिस इज हाउ यू कैन से ग्राफिकली द रिपल इन द आउटपुट ऑफ DC आउटपुट. सो जो DC आउटपुट है उसके अंदर ये दिस इज आवर DC आउटपुट, राइट, and this is we can say ripple, that means AC component. Fine. So ripple factor is a ratio of RMS value of AC component to the average value of DC component. और जितना रिपल कम रहेगा उतना रेक्टिफायर इफेक्टिव रहेगा. बिकॉज रिपल कम, इसका मतलब क्या, तुम्हारा प्रेजेंस ऑफ AC कंपोनेंट कम है. अगर AC कंपोनेंट कम है दैट मीन्स इट इज मोर DC. सो स्मॉल रिपल फैक्टर, दैट मीन्स रेक्टिफायर इज वेरी effective. I repeat students, whatever output we are getting through the rectifier, that is unidirectional, that is DC, but that DC consists of some small fraction of AC component that we called as a ripple. That AC component which are present in ripple, we have to remove. That we can do with the help of next part, that is filter circuit. Next part students, filter circuit. The function of this filter circuit, which removes the AC component or ripple from the rectified output and allows only the DC component. Means what? We did rectifier, that is full wave rectifier. So suppose this is again rectifier. This is AC voltage, AC signal, that is positive half cycle, negative half cycle, positive half cycle and negative half cycle and so on. Now this rectifier convert this AC voltage to pulsating DC voltage, that is unidirectional. So we can say this is pulsating DC voltage. Okay students. Now this pulsating DC voltage consists of AC component also, that we called as a ripple. Now we have to remove the AC component from this DC pulsating voltage. So this you can do with the help of filter circuit. So here we are connecting a capacitor. So this is my filter circuit with capacitor. So how it works? Say this is pulsating DC voltage we have, right? This we can say first quarter. Okay, so as voltage across capacitor increases, the capacitor gets charged. This capacitor gets charged up to point A, and at the end of first quarter, it reaches to maximum value of VP, peak voltage, that is VP. So we can say in the first quarter cycle, capacitor gets charged to point A, and supply current to the load resistance, At the end of the quarter cycle, capacitor gets charged to peak voltage, that is VP. So at the end of the quarter cycle, it reaches to maximum peak voltage VP. Now here voltage across capacitor decreases. अब voltage कम होने लगे. Because of this now capacitor gets discharge, but voltage across load resistor decreases slightly up to the point say B. Means the voltage कम होगा, the capacitor discharged up to only point we can say B. So voltage drop only up to point B. Again immediately it starts charging and it charges to peak value again to up to say point C in the at the end of this quarter cycle. Again, as voltage decreases across the capacitor gets discharged, but discharge up to point D. It reaches to D, immediately it starts charging and it reaches to maximum value of E. So if you see this waveform, TD is a discharging time, TC is a charging time. Means charging is takes from here to here, charging time is B to C, चार्जिंग टाइम D to E. जैसे वोल्टेज कम होने लगता है तो डिस्चार्ज कहाँ से कहाँ तक होगा, A to B. यहाँ वोल्टेज कम हो रहा है, डिस्चार्ज कहाँ से कहाँ तक जाएगा, C to D and E to F. So from the waveform we can say discharging times from A to B, C to D and E to F, and charging time up to A, B to C and D to E. Fine students. So what your output consists of, this is will get the waveform DC voltage. That is unregulated DC voltage you will get after filtration.